These are the instruction notes for Module 2 of the 2019 version of ISBT 211, Module 2 LabVIEW Review. Open up the document. This is the document that gets distributed to the students in the class. I believe I have updated all of the appropriate 2018s to 2019. I think I just caught those. As an overview, what we're doing here is we're making sure that students who have seen LabVIEW before, these students, if they are on the regular path, if they've joined us since the first semester freshman year, they are first semester sophomores, and they have seen LabVIEW during their spring semester, so they've had one semester using LabVIEW in the ISBT 111 course, 111 course, where they were introduced to making the barcode scanner. So they haven't had a lot of experience with LabVIEW, but hopefully they remember it. We probably have an equal number of students who have just joined us as ISBT majors, and for them this is their first interaction with LabVIEW. So it can also serve as an introduction to LabVIEW as well. So I tentatively have it set to review, but it could be an introduction as well. The actual activity is fairly straightforward. I actually borrowed this activity from a tutorial that was presented by National Instruments for LabVIEW users. A lot of the graphics and a lot of the icons happen to be icons and the like that were actually provided by LabVIEW. What we're going to do overall is we're simply going to build a simulated temperature sensor, and then we're going to have a switch to, in simulation, display that temperature in either units of Celsius or Fahrenheit. In addition to showing the students how to use LabVIEW, sort of from the beginning of how to open things up and create a LabVIEW virtual instrument, or VI, which of course is the unit of programming, or what a program is called inside LabVIEW. It also instructs them how to use probably the most important and probably the largest part of LabVIEW, and that is how to create a sub-VI, so that that sub-VIs or sub-code can be used by other programs. And usually in class I go over, after learning how to make sub-VIs, if this is something that sounds appealing to you as a career, maybe someone who wants to computer program or develop algorithms, you can create those sub-VIs, and if they're unique and do something useful, you can go ahead and sort of encrypt them and tie them up so you can't see how you actually did your work, but as long as it works, and you can sell them. There are, of course, lots and lots of companies and lots of individual computer software engineers and folks that create LabVIEW software, make sub-VIs, and then sell their sub-VIs as part of their business. So this is actually something that, if it sounds useful to somebody, they can take a look at. But to the actual lab itself, it's fairly quick, fairly straightforward. There's not a lot of clicks involved. Of course, there'll probably be a lot of questions, so it takes a while for the instructor to get around to all of the different groups. We have 12 computers in the lab, 12 student computers, all running LabVIEW independently. The 12 individual groups should be able to run through this, and when I teach this, it's usually just me running from computer to computer, and following hands that are raised to answer questions. Usually the questions are not too terribly difficult to answer. They simply want to know where to click or where to point to get things working. But again, overview-wise, we're going to make a small sub-VI that converts Celsius into degrees Fahrenheit. Here is the front panel for that little tiny application. Takes a degree Celsius and converts it and gives the output in degrees Fahrenheit. Again, we like to use the word like controls. Controls are input, indicators are output on the front panel. The actual code itself in the block diagram is fairly simple. We're simply going to take the degree C, multiply by 1.8, add 32, we get degrees F. That's just the standard conversion between degree C and degree F. There's a whole bunch of vocabulary in here that it's there because of National Instruments. It's true you can view as an icon, or you can view not as an icon, depending on how you want to see it. Just an individual little tiny box. It's up to you to go how deep you want to go. There's lots of little pictures to show people how to use a mouse. Everybody knows how to use a mouse, and how to wire things up, how to connect the output of one element like the degree C control to the input of the multiply function. Again, for students who have not seen this before, it might sound foreign the first few times, but for the folks who have worked with this for the past semester, it should be hopefully comes back pretty quickly. And then after we go ahead and create that sub VI, we go ahead and save it. I've created a 2019 ISBT 211 folder on the hard drive or the C drive of all of the computers inside the lab, so it should be there. What we're going to do is, after making that first VI, we turn it into a sub VI by number one, creating an icon which we'll use as a sub VI, and then assigning the terminals, which is inside here, and we'll do that real quick. And then once we go ahead and have that sub VI to convert degrees C into degrees F, we're going to build a wholly separate VI. It has this as the front facing control panel, a switch to switch between degrees Fahrenheit or degrees Celsius. It will have a thermometer to display the synthetic temperature and the digital display or the digital readout of this single control. So this is actually two different things. The temp scale and a temperature display that looks like a thermometer. It's not three things. This is not an additional indicator. It's actually the digital display of this indicator. We'll take a look at that. This is the wiring diagram for this very, very simple program. Obviously nothing too huge. It just so happens that the way this is wired up, the temp scale is inside what looks like a box. It's not really a box. It's just wires going around it. What we're going to be using is we're going to use the select function in LabVIEW, and the select function is based on this temperature scale switch. If the switch is up or true, then the wire along the top that connects to the T will come out. And if it's down or off or false, then it will go ahead and select whatever is below it and through it. So in actuality, we don't really save the computer any time, either converting or not converting. In fact, we have it convert all the time. We take the data from a simulated sub-VI that the students have been provided called Process Monitor VI. We make sure that we're connected to the T, or temperature, output of this process monitor. It's just a random number generator that generates some randomly fluctuating data rather than actually using a transducer. And then the actual data, which is output in degrees Celsius, goes up and over and is connected to the top part of this select function. That same Celsius goes through the student-created sub-VI, which converts Celsius into Fahrenheit. Then the Fahrenheit version, which we converted, goes to the false terminal. And then depending on whether the student has selected false or true, or on or off, up or down on the front panel, that goes to the thermometer. And then we go ahead and make yet another VI image or icon for the new program, just to show them how to do that. It's called temp, and then we're out. That's it. That's all there is to it. So it's a very, very simple lab. We're actually creating two VIs. The first VI is the convert C to F VI. I think that's actually what it's called. Let me check right here. Let me see if I can find it. There's some determines. I think down here I say save it somewhere. Save as, there you go. Convert C to F.VI. That was simple. And then we go ahead and use a different one, and I believe we go ahead and save that guy at, that's the convert, says next one down here. And this guy is, I know it's here somewhere, fire save. Maybe we name it very early on. I'm lost. Where are we at? Create a new VI. Type temperature, scale. I know I save it somewhere. Select a VI. That's the process monitor. In hours. Icon editor small, black and white. Okay. File save. Choose a location. There you go. And save it as thermometer VI. Finally found it. It's down here at the bottom. So we're only creating two VIs. We're using two sub VIs in our final program. The one sub VI is provided to the student, and the other one is the one that they created. So let's take a look at this guy. I'm going to go ahead and come back up here to the top and open up LabVIEW and see what we can do. I have a hard copy of the lab, so I'll be referring to that guy as well, but I'll just minimize it. So on my computer here, I have we're in module 2. LabVIEW review. If I go to this PC and go to the Windows C drive, I've created a folder called 2019 ISBT 211. This is what is actually appearing on all of the student computers inside the laboratory room. If I double click it right now, this is all they get is the process monitor.vi, so it's ready to go. So we're ready to fire up LabVIEW. As everyone knows, LabVIEW is a National Instruments program. So in Windows 10, it usually shows up under N for National Instruments LabVIEW. There's two. I have the NXG version. I think only LabVIEW 2019 is installed in the lab. I'm running the 64-bit on this computer. I think it's the 32-bit that's in the lab. Both are equivalent. We're going to open up LabVIEW by selecting it. I think I double-clicked it. I keep forgetting I'm in Windows 10. I think I only had to click it once. Let's see if it runs it twice. No, we're good. You may get a Welcome to LabVIEW running it for the first time window that shows you, hey, do you want to run a tutorial? Do you want to learn different things? You can just close that. This happens to be the sort of the splash screen or the start screen for LabVIEW in 2019. We're not going to create a project. It's not that involved. We're not going to go ahead and open existing. We're going to create a new one. So File, New VI, and that's all we need to do. We'll lose that guy right away. If you recall from LabVIEW, we're going to get two windows. We're going to get a front panel window, and we're going to get a block diagram window. For those students who don't remember from last spring, I try to emphasize what's going on. I'm going to minimize this guy over here just to get a little more thing on the back. I try to introduce the students who haven't seen it before and minimize what's going on and reintroduce the students who've seen before. Why that LabVIEW has two windows. I've introduced LabVIEW in class right before this lab. For those people who haven't seen it before, so they have seen LabVIEW run and use it. We're going to use this a little bit more deeply today in this lab. Again, the front panel, very simply, is where we put controls and indicators. It's where the LabVIEW VI gets its input and produces its output. And then in the block diagrams where we actually calculate the answers. I also mentioned in lecture that LabVIEW is serving as our model component for this semester. So I try to use that metaphor as often as possible, that a model takes on input information and then does a calculation and then spits out some sort of knowledge that we want to know. So let's go here. So let's go ahead and go to the first part of this guy. I've opened LabVIEW, and I want to create the front panel to my brand new VI. I'm going to head over to the front panel. I'm going to right mouse click, pull up the controls. I'm going to hover over numeric and grab a numeric control. Click on it. Again, you don't need to hold any buttons. You just have to move the mouse, drop it there, and we're going to call this guy degree C because that's what we're going to convert. And again, as soon as we create something on the front panel, we also get another version of it inside here. If I go ahead and right mouse click, do they actually have view as icon? They do down here. View as icon is the default in 2019. If I click this away, it sort of looks like that. I actually prefer the new default. They just take a lot of time in the lab to mention you can switch that. But there we go. So that's again, showing the metaphor of outside the box and inside the box. This degree C and this degree C are identically the same object. It's just looking from the inside out. This is looking from the outside in. Our output is going to be the converted degrees Fahrenheit. Right mouse click, go to numeric. For inputs, we use control. For outputs, we use an indicator. Those are the terms. So this guy over here is going to be degrees F for Fahrenheit. Fantastic. Yes, it turns out that the lab already has some values inserted in there, but we don't need that right now. It goes through some verbiage and says, oh, by the way, you need to connect the degrees C to the degrees F. Sometimes I'll go ahead in lab and press the run button and show that nothing happens because we don't have any instructions for the computer to actually make this conversion. So I need to multiply by 1.8, so I'm going to right mouse click and go to a numeric folder and grab a multiply. Place it somewhere close to the degree C. For students who haven't seen this before, I think they've all been introduced to it because I introduced them in class. It's sort of awesome that you can automatically hover next to any terminal connection and click and then wire this over. Sometimes under tools, or window rather. Is that where it's at? Front panel. I'm looking for the tool panel here. Tools, advanced. This is from an old version of LabVIEW. What do I want to see here real quick? So I think it's here. I'm gonna go here to tools. I thought it is view the tools palette. Maybe it's under window. Show project. Well, I guess it's not there. All windows. No, we're good. So sometimes I'm trying to figure out where students get into trouble of not having their cursor automatically change. I'm trying to see, maybe it's over here. Here it is. I found it. Some students will either find an instruction inside a piece of LabVIEW that I've used, or LabVIEW NI stuff, or they'll wander over here to the View menu and they'll show the Tools palette. Here's the Tools palette. This is a really, really old remnant of like LabVIEW 2005 or something like that. I mean, remember LabVIEW's been around for 33 years. I personally prefer to have this automatic tool selection on. If you intentionally turn it off, then when you hover, you won't get the wiring tool. You only have the pointer arrow. If you press the finger tool, you'll only have the finger tool. And sometimes when I walk around, I'll find students who have pressed view, found the tools palette, and the first thing they like to do is turn off the automatic tool selection. Not sure where that comes from. Again, maybe if I read these instructions carefully, because I did copy it from a rather old instruction manual, maybe it actually says to do that. If I see it, I'll remove it. But I just usually leave the tools, auto tools available. You see as I'm hovering around here, it automatically switches, which of course is the preferred method. And then I just usually make the tools thing go away, so that's not happening. So if LabVIEW is not behaving properly, if it refuses to automatically turn into the wiring tool when necessary, or turn into the move tool when necessary, you may have to go over here to View and make sure the tools palette's automatic. I use it so infrequently that it took me forever to find out where the damn thing was. It's over here in View. We need to multiply this by 1.8, so we need a constant here. There's two very synonymous ways to do that. One is to right mouse click, go to numeric, and find a constant. In this case, it's a floating point number, so I need a double numeric constant. I'll grab one of those, drop it, and then I'll type in 1.8. That's fantastic. And then I'll wire this thing in. A shortcut is to undo that. Control Z, Control Z, Control Z. A shortcut is to hover over the terminal itself where you want to connect a constant, right mouse click, and from there create a constant, and it automatically wires it up to the correct thing. So it's however you want to roll. You can go ahead and put your own constant there and change its value. I had to change its value anyway, or right mouse click them. They're synonymous. We then need to add 32, the offset. So I need to go ahead and right mouse click, go to numeric, grab an add, and to this value I need to add 32. So for this one, I created a constant. I think I'll just use the other method here. Go to numeric, grab a constant, put it here. Doesn't matter what you want to do. And this guy is going to be 32. And then wire this up. And then wire up the output. So now we're done. That's the entirety of the programming for this very quick VI. To convert C to F, you multiply the degrees C by 1.8. You add 32 to get the 0 offset, and you get degrees Fahrenheit. We can double check it. 0 degrees Celsius, which is where water freezes, I believe, should be 32 degrees F. So if I go ahead and run this, it worked. Up here, if I go ahead and put in, say, close to room temperature, which is around 21 degrees Celsius, which is probably the temperature of the lab, it's around 70. I think most of our labware is calibrated at 20 or 25 degrees C, which is 77. And just for fun, for those students who have memorized this, the degrees C scale and the degrees F scale are identical. They give you the same value at -40, and we can go ahead and double check that. Now this guy can be whatever you want because we're going to use it later on. I'll put it back to 25 degrees. That's actually hot for the lab. 20 degrees C is about right. 68, 70 degrees. Really doesn't matter. Let me see what's next. So we have a VI, and I think we're supposed to save it now so that I don't lose it. So I need to go ahead and save it. So File, Save as. I am going to save it in Windows C 2019. I'm going to save it right next to Process Monitor. Please don't overwrite it. And I'm going to call this convert C to F. You can call it whatever you want, but it's a Windows system, so we can have spaces in there. And say okay. So now we're good. So it has saved it, and fantastic. That was step 1. We have 3 steps in total. We need to convert this into a sub VI. There's two things we need to do. One, we need to change it. So we don't need to, but it's always a good practice to change what it looks like as a sub VI, which is this area right here of this icon. And then 2, we need to adjust how it connects to the other programs. So the first thing they have us do is change its icon. So I'm going to right mouse click on its existing icon and go to edit icon ... And up we go. Wait for this PC to wake up. Again, this is a very, very old school 8-bit editor. It looks like an 8-bit Nintendo. We can go ahead and, this is the fore color, this is the back color. Right now it's black. I could go ahead and start writing on it, but that wouldn't be very fun. It's not a very pretty icon. You can see that here. It looks like, typically what I do is I erase what is there by default and draw new. You can, if you wish to, erase this bounding rectangle. But if you erase this bounding rectangle, then it turns out that your VI is just sort of floating in space, and the wires will wire to the edge of the icon, not to what you've drawn. So it sort of looks weird that the wires connect to nothing. So I always sort of suggest that the students only remove the center of this picture and leave the bounding rectangle. If they, by mistake, remove the bounding rectangle, I suggest that they put it back where it was. So what I'm going to do is I'm going to grab the lasso tool or the select tool, and I'm going to select inside that rectangle, and I'm literally going to press the delete key on my keyboard. There's no special mouse action, and when I delete it, it goes through. You'll notice if you're a graphics person, you realize that this is now transparent because it's been removed. Maybe I want a white background rather than being transparent. So what I'm going to do is I'm going to switch the foreground color to white. And then I'm going to use the paint tool, and then I'm going to paint this white. So now it really is white, whatever you need. You can make it as pretty or as ugly as you'd like. The LabVIEW, rather the handout says that we should just literally create a VI that says C to F. So I'm going to do just that. I'm going to pick another foreground color that's different. I'm not being very particularly awesome here. T for text. I'm going to click over here, and I'm going to type in a giant C. I tried to make that a capital C. Shift C. It's just not very large. I can go ahead and change. If I edit, I think over here I can change the size of the fonts. Let me check. Select font. There we go. And right now it's 9. I'm going to go ahead and up this to say 16. And so, okay. So now when I click C, it's pretty big. It's not the world's largest. And then I'm going to go over here. I'm going to use F. And if it's not exactly where I want, I can use the arrow keys before I move away to make that C to F. And then I want a nice arrow in the middle, so I'm going to go ahead and grab my pencil tool again. And I'm just going to paint in the middle here with a little arrow. The students can be as awesome or as not as awesome that they can make colors. You can do whatever you want. I'm going to try to make this a nice little arrow color, or arrow shape. Fantastic. That's wonderful. Now down here is a miniature version of what C to F is. It looks fantastic. When I'm done, when I'm happy with this, and again, this is a little VI that converts Celsius into Fahrenheit. I'm going to press OK. And then what happens is it disappears, and it shows up where the icon used to be on the front panel and where the icon used to be on the block diagram. The other thing we need to do is we need to connect the degrees Celsius and the degrees Fahrenheit, both the input and the output of our sub VI. This is the default. I'm going to right mouse click on the connection pane, and what I want to do is I want to view all of the patterns. Well, it turns out that I have one input and one output. Most importantly, I have two things. One of them are inputs, one of them are outputs. So I'm going to grab the one input, one output pattern, Click on that. So now I only have two terminals, a terminal on the left side, which I like to keep it on in, and a terminal on the outside, which is out or goes out. And we need to connect them. The way that we connect them is we just use the wiring tool as it shows here. I'm going to left click on the input and then left click on which control it should connect to. It connects to this control. This happens to be a double precision real floating point number, and floating point numbers are orange, so that's why that guy's orange. And then I need to connect the output. I connect to the output, connect to the output, and now we're both connected. So we have colors for all of these connections, input, output, and press File, Save. We are good to go. This guy still works. I can go ahead and change it and run it. Just turning it into a sub VI does not change whether it works or not. If you recall, what it has done now is rather than waiting for a human to put an input into this value, we can now wire it up from another LabVIEW VI that will actually wire a value in here. This VI will create the degrees F, and then we can take that output through another wire, which is why the sub VI works. So I'm going to file save this guy, so he's good. I'll switch the page. We actually need another VI. The students are welcome to close this if they want. I think I will do that. Closing just the block diagram keeps the front diagram up, but closing the front panel closes the actual VI. So I'm going to go ahead and file new VI again. So I have another VI. This is VI2. This is where I'm actually going to build our second VI, which again is not too amazingly difficult. And I don't need to do this. That was Windows 10 wanting me to register my video software, which I'm using to run this screen capture. So here we go. So I'm just going to fill this up as it says here on the in the lab handout. I need a switch that's under the Boolean vertical toggle switch. I can make the vertical toggle switch as large or as small as possible. I'm going to grab one of these guys and make it big. It's always fun to see this thing be nice and big. I'm going to change its title from Boolean to temp scale, TEMP SCALE. Because I made the switch big, it might be better to make this guy big. So if I select it and then go up here to the font, I can change the size up to like 18. That wasn't very large, was it? Size to, how about 36? That works fine. Also, see if I double click this, I can see up here it says size. I can smaller or larger, control equals or control minus. So to make it bigger, I should be able to hit control and equals, which is this guy. There it is, which is the same as the the control equals actually the control plus, but the plus is the shift, or I can control underscore and makes it smaller. Make it as big as possible. There's temp scale. Fantastic. And then on that temp scale, I need to have two labels, one for degree C, one for degree F. These are just free labels. Now, they don't actually belong to the switch. If I move this switch, the temp scale comes along with it. So what I'm literally going to do is I'm just going to write on this window, and I just double click and write degree C. And again, it doesn't look very good. It's so small. Select it, and I just learned the trick. If I hit Control plus, it'll make it big. Unfortunately, it's getting big, but I don't have a large enough box to hold it. So I need to make these a little bit bigger. There we go. And I can do the same thing with degrees F, or I could just go ahead and copy this. I can Control C or copy. But since this is a window machine, I can hold down the control function and click and drag. And then I can make this guy degree F. It's however you want to do it. So now, because I wrote degrees C on the panel, again, I just wrote them there. They're just sitting there. Because I've wrote degrees C and degrees F, if I click this up, it looks like the switch is pointing to degree C. And if I push it down, it looks like the switch is pointing to degree F. The only thing that Windows or LabVIEW sees is this temp scale on the inside. Also on the front panel, I'd like a numeric thermometer. This is our guy here. We're going to call this temperature, T-E-M-P-R-A, temperature. Again, it'd be nice if it was larger. I can make the box larger, but the font size does not get any bigger. So if I Control plus, make it a little bigger, I'm going to make that even bigger so it will fit inside the box. Wonderful. You can get as artistic as you like. There's temperature. I'm going to make this guy a little bit bigger. There's a little tiny fill handle, a little blue fill handle down here. Make it big. LabVIEW will be changing the value. This is just me changing the value with my mouse, but this is just a regular old thermometer. I mentioned that our front panel will also include the digital display. So I need to right mouse click on this guy, go to visible items. Right now the label's being displayed. I can make the label go away, bring that back, and then I can right mouse click and go to digital display, and then there's this guy. And it too is kind of small, so it's however you're going to do it. Control plus 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 plus. There we go. Make it bigger. Fantastic. Because it's bigger, doesn't fit inside this box. I need a bigger box. There we go. Wonderful. So I think that's all we need to do for our digital display. So again, this digital display is actually attached to this thermometer, which is also the label is also attached to the thermometer. So it's one unit. They all belong together. I didn't put an extra free label there, but that's our guy. So now we're ready to go in here. So how do we do this? We're going to take the temperature scale, move it over a bit. We're going to get some data by using a sub VI that's provided. So if I right mouse click and go down here to select a VI, I'm going to grab a sub VI, and it turns out we saved our other VI in 2019-11, so it'll pull it up. I'm going to click on process monitor VI and say OK. And when I drop it, now notice I can't drop it on the front panel because it doesn't belong on the front panel. It only belongs on the block diagram. When I drop this, there's our guy. This is if I right mouse click and visible label this guy, I'll see it's called process monitor VI. We don't need to do that, but there it is. This process monitor happens to output a simulated pressure, a simulated temperature, and a simulated volume for some mythical process that we want to check. It also has an index or a random number generator if you want to control it. We're not using that today. So this guy, which was provided by National Instruments for this particular tutorial, has one input and three outputs. We're only using one of the outputs. What I want to do is I want to grab a couple more components. I need to grab a select command, which I believe is under the comparison function. Equal to 0 select. It's this guy right here under the comparison. Grab it and stick it there. And then what's going to happen is the temperature is going to come over here. I'm going to use my left mouse click to pin this down, move it up and pin it down again, and move it over and pin it down again, and then come into true. So I just made a wire that went up and over and down. I intentionally bent it around here so you can see the damn thing. And then I'm going to go ahead and attach the temp scale to this question mark. So that's going to control whether the value from the degrees C gets shown or from our conversion. And then I need to convert it. So I'm going to right mouse click, go to select a VI, and instead of using process monitor, which was created by National Instruments, I'm going to use convert C to F, which was created by the students. And I find out that the create C to F behaves very well, identical to a sub VI that was created by the professionals at National Instruments. And again, you can make as many professional sub VIs that do amazingly cool things and give them away to friends and family, or you can go ahead and sell them. So I need to take the value of degrees C and put it as an input to that sub VI, and then take the output and put it into the false down here. I can leave this blare, or I can go ahead and right mouse click and visible items, the label, convert to CI, whatever we want to do. And then out comes the output. Right there it is. So this is the entirety of our LabVIEW VI. I can go ahead and run this thing. If I run it once, I'll see that it has created a simulated temperature, and right now it's in degrees F, so it is converting. Well, it's converting all the time, and then showing us the degrees F. So right now that simulated value is 79.5. If I run it again, I'll see that it's stayed still. If I run it continuously, we'll see that it's actually bouncing around a bit. This is just running really fast because, again, this VI. If I want to slow things down, I can stop it, or I can press the highlight execution button, which looks like a light bulb. And what it will do is it will show the cartoon of what's actually happening. So this value is 30.51. 30.51 goes over and down. 31 point, the old value, 30.1 goes down here, gets converted and down to there. And depending on what the switch is, it will display the values. So right now we're reading in degrees Fahrenheit, and it's slowed down because it's showing this this animation. If I go ahead and turn off the animation and then click on degrees C, you'll notice it's hovering around 30 degrees because the degrees C is much lower than degrees F. So this is working just fine. All it's doing is it's using the students generated C to F converter. We're able to use a sub VI that does this. So I stop this, and then the only thing it asks us to do is, let's see here, moving to the next page. It wants us to save this as temperature, thermometer, my bad. So I'm going to go ahead and file, save, and I'm going to call this thermometer. Wonderful. And it just asks us, this is not a sub VI, but it asks us to practice using the editor again. So if we we edit the icon, we can spend some time doing this again. I'm just going to select, I'm going to grab this stuff in the middle, I'm going to press the delete button. It's transparent, so I want to fill it with white to make sure it's not transparent. Grab the paint bucket, fill it with white, and then it suggests that we go ahead and take the T and write temp. I'm in white because I'm an idiot. Come back here. Change this back to whatever color you want. How about, that's a lovely color. We're in TMP. It's still large. Wow, it's too large. I'm going to Control Z and undo that. I have to go back here to the tool, edit, select font, and take this back down to say 10. Cool. That color wasn't very useful to see. I'll make it more red. There we go. TMP. Now it fits. Using the arrow keys to move it over. It's fantastic. And then you can spend as much time as you'd like making a thermometer. I'm going to go back to black here. I'm going to take a vertical line and go here. I'm going to take a vertical line and go here. Take a vertical line and go there. And then I'm going to take the pencil tool and make a little cap for it and make a little bulb for it if I can. Didn't do a very good job of not hitting this side of this icon. Wonderful. And I'm going to take red alcohol and fill this part of it. Oh, it's a thermometer. It's beautiful. I'm going to say okay. So now our temp program has a nice little icon. I'm not using it as a sub VI, so I don't need to assign the connections, but if I wanted to, I could. So file, save, and we're good to go. So now we have a VI, if you get rid of how it actually works, that if I run forever, simulates a temperature, and then I can go ahead and change whether I want it in degrees C or degrees F. And again, this semester we're going to be using other LabVIEW VIs to simulate things. This is just modeling a temperature system with an integrated thermometer that displays things. And with that, I think that's close to the end. Save and save as. So by the time we are done, I believe the files, we have the process monitor that was already there, and we have convert C to F, and we have thermometer. I asked the students some questions of actually running through this process on Canvas. I'll double check. I don't think I asked them to actually upload their final VIs. We could do that if you'd like. I have to review it, but I don't think I have them somehow emailing this to themselves or putting on a shared drive. But just the experience is pretty cool. All right, there you go. That's Module 2, the LabVIEW Review, or the LabVIEW Introduction to actually using LabVIEW and using LabVIEW to create sub-VIs and using sub-VIs.